Hello, everyone. Our next speaker is Kamalov. So please welcome him to I think, the last talk before lightning talks. Thank you.
Yeah. Hey everyone. Uh, Thank you very much for sticking around. I'm very happy to be here, and thank you for the organizers. My wife, in particular, will be very happy that I got a new hat. She wanted me to get it for a long time. Okay, so today we're gonna talk about behavior-driven development. This is a testing practice. And on the agenda, I have three things. I want to give an overview of what behavior-driven development is, how you can incorporate it into your Python project, and how we incorporate it into our open source tooling. Okay, so uh, who is actually behavior-driven development for? It's for usually bigger teams that have more than one stakeholder where you need to talk in more than one language, say programming language and a normal human language. And I will posit that testing in general in teams like this and projects like this can be a lot better. So how does the testing work in a regular company? Yeah. So a stakeholder requests a new feature from the team, and the dev team then has a meeting. They split the story into multiple tickets, and then they implement the feature. And ideally, they use a nice testing library like the hypothesis or the robot and PyTest, and everything works fine. And then in the end, you have a product owner or a QA person that clicks through the application or like does all the manual tests, and they have to put it worked, and then it's deployed, and like that manual testing usually doesn't happen ever again. And the problem here is that you will have a new feature implemented in the future, and that new feature might break the old feature, and the only way you will find out is if the client complains, in the middle of the night, hey, the train is broken, let's do something. Okay, so how can there's a better way to do this, obviously. So how could it work better? Yeah. So let's say a stakeholder writes the same feature. Dev team again splits up the user story, but before they start working on the user story, what they do is they implement tests that are specific to that user story. So they look at the behavior, they look at the goals, and then they build a test for those goals. And then they implement the feature, and once the feature is implemented, the user story then, because there are already tests, it tests itself. So you can set it to test automatically on every pull request, on every merge to the main, and hopefully, the life is green and you can relax about tests. So this is the basic premise of behavior-driven development. This is a term coined by Dan North in 2009. So the keywords in his description of behavior-driven development is that it's a multiple stakeholder process. So you want to have a system where you have multiple stakeholders that require behavior. Another keyword is high automation. So we want to make the entire system be highly automatized. And the third keyword is well-defined outputs. So before we start working on any feature, we want to know very well-defined outputs into what this feature is supposed to do. Okay? So how does it actually work? Yeah. So we have to start by establishing clear goals. Then we follow by drawing up the features. We involve the stakeholders in the development of the features. So the language with which we describe the features, we have to involve the stakeholders that are requesting those features so that we're all on the same page. Then we draw up examples that describe the desired behavior, and then we automate the examples. And we have to use keywords such as should and ensure in order to make sure that we clarify the behavior and the responsibilities of the system. And in the end, we can use some mocks for systems that are outside of our control, or maybe systems that are not yet implemented. Okay, just want some water, sorry. Okay, so the problem here is obviously the involvement of multiple stakeholders. Yeah, so because stakeholders most of the time do not speak the same language. You cannot get a marketing person to tell you in Python how your unit tests should be written, right? So the way to do it in behavior-driven development is by use of this language called Gherkin. Yeah. So what Gherkin is let's say we have a goal called refunded items. So I have a shop, and refunded items should be returned to the stock. Yeah. This is the story we're going with. So we start with a scenario definition. So a scenario here is a keyword, and what comes afterwards is a description of the scenario. So refunded items are returned to stock. So this is the first step of the scenario. Given I currently have 3 black sweaters left in stock, when a customer returns a new black sweater for refund, then I should have 4 black sweaters in stock. Okay? And my guess is that if all the managers in the world learned how to speak like this, we would solve like world hunger next week. Yeah? Okay. This also applies to programming, so you could write unit tests in this manner, yeah? So making sure that lists behave the way you want them to behave. But then, this is a language, but we want to incorporate this into our Python projects. So how do we do that? And that's where Behave comes. Behave is a Python library, you can just install it, that allows you to implement behavior-driven development inside your Python project. So in Behave, you will have a Python file that defines steps for you. And the syntax will look familiar to you. We have decorators such as given and when and then, and we can define functions that then implement those steps. Yeah? And in the arguments for these decorators, we pass a string that is supposed to be mapped to the step of the Gherkin language. So for example, if we were to look back at our example with the refunded sweaters, you can see that I can take, I can create a stock class, for example, and then I can write a given for the first given, and then for the when, I can write a function where, I'm returning it to the stock, and then in the end, in the then step, I'm making an assertion that the total count will be the count that's provided in the function. Okay. So how do you incorporate Behave into your Python project? Usually you'll have a test directory, and inside this directory you'll have a features directory where you will define your features, and these files with .feature are the ones that are written in Gherkin language. So these are the ones that you usually are getting from other stakeholders. And then you have a steps directory, and this is where any feature step that you define in the features has to be mapped somehow into the steps. Okay, so what is a feature? A feature is basically a multi-step description of a goal that we want to achieve. And what you have inside features is a bunch of scenarios and a background. Features can be very complicated, so you can have, like I said, multiple scenarios. You can have tags, you can have descriptions, and you can have a background. Yep. So what is a background? Background is a series of steps. It allows to add context to scenarios. So what it means is that before each scenario, the background is run. So you define it only once, and then before every scenario, it will run again and again. And it's a good idea to keep it short and vivid so that people know what's going on. Yep. Here's an example of a simple background statement. Okay, so what is a scenario? Scenario, it describes the isolated behavior of a feature that we're trying to develop. And it's also composed of the steps. And we're using it in order to test a single behavior. So ideally, you're not testing multiple behaviors in a single scenario. You should write different scenarios for different behaviors. Okay, so this is the syntax of a behavior, and then inside the behavior and inside the scenarios and background, you define steps, and steps are the lines basically that start with the words given, when, then, and or but. So each step is implemented in Python using that are defined in the steps directory. Okay, so a given is a statement. So we see here, given some condition, this is a statement that puts a system into a known state. When is used to take an action that a user or someone else will take on the system. And then is the function that lets us observe the outcome of the action. Yeah. And and but are more like a nice to haves. So let's say you have a scenario like this where you have multiple givens and a couple of thens. And so you can just write it as and the behave will understand that the second and, for example, is also a given. But there in the bottom, it should be a then. Okay, so let's have a look at example implementation. Our example implementation is a project called FAL. It's an open source data tool that we're working on at Features and Labels. We are trying to make it easy for people to run Python in different environments and make it easy to define your environments and run it in like different systems. And the first audience that we're working with is people that work with dbt. dbt is a data processing tool. It's a transformation tool written in SQL. I mean, it's written in Python, but it's a SQL transformation tool, and we're building a layer that allows you to run Python on top of your dbt project. With FAL, what you can do is instead of SQL models, you can have Python models. And you can associate your Python scripts with SQL models, and you can make it so that they run, let's say, at every time a SQL model runs. You can interact with your dbt project from a Python notebook, and yeah, we have a runtime management system that we're working on right now. Okay, so this is our file repository, and I'm just gonna, I think it's working. Yeah, this is our file repository. Yeah, we're trying to do more with dbt here. So we have an integration tests directory, and that's the directory that holds all of our behave tests. And if you look at the projects directory, we have a bunch of projects that describe different settings in which dbt and file can be run. And this is our features directory, and that's our step definition. So we're going to open a feature as an example. So this is one of the core features of our application, and we define a given there. And for example, in that second when statement, we're passing a string that is supposed to be run during the test. Yeah, so we have a bunch of features, a bunch of scenarios for this feature, and here we have an example run. So we set it up so that GitHub Action runs these features at every pull request, and right now a single run takes about 18 minutes. So you can see we have 17 features, 91 scenarios, and 474 steps. We do it every night for different databases, and we do it, like I said, for every pull request and for every merge into the main branch. This is a new feature of our application. So we're now building an adapter to dbt where fal basically allows you to run dbt seamlessly, and it behaves as if it's not even there. And for that, we have to write some brand new tests. And this is something that I've been working on recently. So that's the first feature that we have, and it's fairly simple. When you run that dbt command, you have 4 models, and they should be calculated in that order. Yeah. So what's very important is that like model B does not run before model A. Okay. So in our steps directory, we have description. We have actual implementation of the steps, and so if we look into that's the order function. This is where we get the models from the context. We get the list that's passed by the user, and then we run the models, and then we make sure that the sorted models are same as the ones that are expected. Okay, So then, like once I've written these tests, now I have to make sure that they run automatically and they run at every pull request. So I set up GitHub workflow, and I'm just going to show you what our workflow looks like. This is the workflow directory, and that's our workflow YAML. This is where we set the triggers for the run, so on pull request, on push, on schedule, and this is the setting up of all the dependencies that we need. And these are all the environment variables that we need to set because we're testing against various different databases, such as BigQuery and Snowflake. And in the end, right there's a command, behave, where we are testing running the actual tests. And in the end, if something fails, I get a Slack notification on my phone that tells me that this test failed. Time to have a look at what's going on. Okay, so this is the first time I ran this run, and obviously all of my databases failed in the beginning, and it took 1.5 minutes. And then with a bit of work, I got DuckDB working, but as you can see, the other databases were still broken, so I had to spend a bit more time working on that. And then with a bit of work, BigQuery and Postgres were working, but Snowflake was refusing to work. So what do you do when something refuses to work? You put it in a ticket, and you forget about it for now, and let someone else take care of it in the future. So the total duration of a run for something like BigQuery right now takes 4 minutes. And these are the total runs that I had yesterday night. So already we have 110 runs. And it's already, whenever somebody pushes onto this, now we are running the tests and making sure that they don't merge something that breaks something for someone. Okay. So in summary, yeah, pip install behave. They have great documentation. It's a very easy system to work with, and it really helps us as a team feel safe about our product and that it works for our users. This is the team at Features and Labels. Yeah, I couldn't do this presentation without them. They're all very awesome. And we recently raised money, so we're hiring. So if you're interested in working for building data tools, get in touch with me. Okay, so thank you.
Yeah, thank you for the talk. And it's time for QA.
Hi.
Hi.
Thank you. Great presentation.
Thank you.
I wanted to ask, how do you ensure that people who write these steps, that they don't write the same step in a different way? Do you use an autocomplete extension that you've written, or do you have a person that vets all of these written feature files and just discards the double written steps?
That's a very good question. So at the moment, you're not allowed to have a feature that has exactly the same string, right? So if I were to define a step in Gherkin, and then I write a step implementation in Python, and then somebody else decides to write it in a different Python file, then we will see a conflict and it will not work. If somebody is ambitious enough to go around it and write their step anyway, I mean, it's not really breaking our system. It might be a little bit of wasted effort, but we're all fairly lazy in our development, so before developing, we would check what other people have done. But we don't have a system, like a formal system for that.
Okay, thank you.
Yep.
I have a question. How hard? Yeah, I'm here.
Oh, hi.
Hi. Thank you, by the way, for presentation. I just wonder how hard is it to refactor these tests? Like you have these configuration files that base on strings And
Yeah.
Yeah, I just wonder, have you faced any issues with that?
No, no. So because the strings are written in one language, right? And so it's like it's written in Gherkin, and then your step definitions are in Python. So you can, in theory, change both the way we want, right?
Yeah, but you have to search for them, and yeah, no.
I mean, like if we're testing, for example, on a small scale, you can just run the test and see what fails, and then go from there.
Well, okay, thank you.
Yeah.
Anyone else?
If not, then thank you for the
Cool.
talk once again.
Yeah. Thank you.